A 1-ton animal is walking across damaged ground. It is not doing anything spectacular. It is grazing, moving, pressing its weight into the soil. In 2009, 23 American bison were moved from the United States into the Janos grasslands of northern Mexico. The simple version of the story is this: the bison came back and the land recovered. But that is not the real lesson. The real lesson is the mechanism. How can a large animal help restart a damaged grassland? And why does that matter for water, soil, plants, insects, birds, and the whole food web? Janos in Chihuahua is a vast biosphere reserve. From the air, it looks like an open, dry landscape. Grass, shrubs, bare soil, and a flat horizon. But grasslands can decline quietly. They do not always collapse in one dramatic event. They thin out, the soil loses plant cover, roots become weaker, rain stops entering the ground. The surface becomes hard, and slowly, a landscape that once captured water begins to lose it. For more than a century, bison had disappeared from this region. In their place came livestock, roads, fences, and a different way of using the land. That absence left a broken ecological engine: dry soil, weaker roots, less water entering the ground, and fewer living organisms below the surface. Healthy grassland soil works like a sponge. Dead leaves, roots, fungi, bacteria, insects, and small tunnels all create tiny openings where rain can enter and stay. But when vegetation becomes too thin, the sponge becomes a crust. Below that crust, the root zone weakens. In a dry land, roots are not decoration. They are infrastructure. They hold the soil together. They feed microbes with carbon, and they help water move deeper into the ground. When roots die back, the soil loses structure. Then the living part of the soil slows down. Microbes, fungi, beetles, ants, and termites lose the organic matter they need to work. So Janos was not facing only a lack of grass. It was facing a broken loop. Less plant cover meant less water infiltration. Less infiltration meant fewer roots. Fewer roots meant less microbial life. Less microbial life meant weaker plants, and weaker plants meant even more bare ground. This is why simply spreading seeds is often not enough. If seeds fall on hard soil with no pores, no moisture, and little microbial activity, they cannot root, stay moist, or survive. The soil must be reactivated first. So what restarts it? This is where the bison become important, not as a symbol, but as a physical process. A bison does not change a prairie through one single action. It changes the land through a chain of small actions: walking, grazing, rolling, digesting, and moving again. The first effect is mechanical. As a herd moves, thousands of heavy steps create small pressure points in the surface. This is not like a plow turning everything over. It is scattered pressure across the ground. In a dry land, that matters. A small hoof print can trap dust, slow runoff, protect a seed, and hold moisture for a few hours longer. That can be enough for pioneer plants, the first colonizers of bare ground, to get a foothold. Recovery often begins like this, not with one dramatic intervention, but with many tiny openings where water, roots, and microbes can reconnect. Then comes wallowing. Bison roll in the dust to shed hair and remove parasites. Each wallow is a shallow depression in the ground. Some are used again and again. To a human eye, it can look like damage. To a grassland, it creates variety. Some wallows hold water after rain. Some expose mineral soil. Some attract insects. Others favor flowering plants. Each depression becomes a small microhabitat, a tiny ecological niche. Before restoration, degraded land often becomes too uniform. The same hard surface the same lack of shelter, the same absence of structure. Bison disturb that uniformity, and in a dry land, variety is survival. The third effect is invisible at first. Bison move nutrients. They eat in one place, digest while moving, and deposit dung somewhere else. That dung contains organic matter, nitrogen, phosphorus, seeds, and microbes. It feeds beetles. Beetles bury it. Soil organisms break it down. Nutrients return to the root zone. This is not instant greening. It is the slow restart of the nutrient cycle. For years, the most important changes may look small from above. A few more plants, slightly better infiltration, more dung beetles, more roots, nothing dramatic. But underground, the loop starts turning in the other direction. More vegetation gives more shade to the soil. More shade lowers evaporation. Lower evaporation keeps moisture in the ground for longer. Longer moisture helps roots grow. More roots feed more microbes. More microbes improve soil aggregation, the crumb-like structure that lets soil breathe, hold water, and resist erosion. That is the chain reaction. And in Janos, bison were not working alone. One of the most important partners is much smaller, the black-tailed prairie dog. Prairie dogs are often treated as pests. They clip vegetation. They dig burrows. Ranchers have historically tried to remove them. But prairie dogs are not predators. They are small herbivores and burrowing engineers. They feed mostly on grasses and other prairie plants. Their return matters because it shows that the vegetation layer is functioning again. And once prairie dogs establish colonies, they reshape the land even further. Their tunnels aerate the soil. Their mounds mix deeper mineral layers with surface organic matter. Their grazing keeps vegetation short and patchy. Their burrows create shelter used by many other species. Burrowing owls can nest in abandoned burrows. Snakes and invertebrates can use them. And the endangered black-footed ferret depends heavily on prairie dogs for food and on their burrow systems for habitat. So when grassland structure improves, the food web does not return one species at a time. It reconnects through loops. Grass feeds herbivores. Herbivores feed predators. Dung feeds insects. Insects feed birds, reptiles, and small mammals. Pollinators follow flowering plants. Decomposers follow dung and dead roots. Raptors, coyotes, foxes, and badgers respond to prey. The ecosystem is not a ladder. It is a set of interlocking loops, and the bison were one missing force that helped those loops restart. But this story also needs limits. The simplified version makes it sound as if 23 animals rescued a dead desert. That is too simple. Janos was never an empty wasteland. It is a large, protected landscape with existing grasslands, prairie dogs, conservation work, monitoring, local communities, and land use tensions. Bison are one factor in a broader restoration strategy. They are not a magic switch. The herd did grow. Official Mexican conservation reporting indicated roughly 140 bison in 2017. Later public estimates described more than 200 animals. Bison from Janos also helped seed a second herd in the Maderas del Carmen Reserve in Coahuila. That is a real conservation success. But success creates new problems. A herd founded by only 23 animals carries a genetic bottleneck risk. Managers need long-term monitoring and better connectivity between conservation herds. A growing herd also needs space, and space in northern Mexico is shared with ranches, fences, cattle, roads, private land, and water needs. The Chihuahuan Desert region is exposed to drought, heat extremes, and pressure on groundwater. If drought intensifies and water extraction continues, even restored grasslands can be pushed beyond their limits. So the lesson is not, bring bison anywhere and the land will heal. The lesson is sharper. Some ecosystems cannot be repaired only by adding machines, seeds, or infrastructure. They recover when missing processes return. Movement, grazing, dung, disturbance, burrows, roots, microbes, time. Remember that one-ton animal walking across damaged ground. It was doing what bison do, moving, grazing, rolling, and depositing dung. But each ordinary action helped restart something the land had lost. Janos changes the question. Instead of asking how we force life back into a degraded landscape, it asks, which missing relationship is preventing this landscape from healing itself? In Janos, one answer came on 4 legs. The bison are one missing force inside a larger prairie machine. Not the only force, but the force that helped restart movement, grazing, dung, disturbance, and habitat variety. Janos becomes a blueprint, not everywhere, not automatically, but in the right grasslands with the right management, the return of large native herbivores may be one of the simplest ways to restart carbon, water, soil, and biodiversity processes. The prairie is not empty. It is a living machine, and sometimes the missing part is alive. There are grasslands, river systems, and coastal zones around the world where the same question applies. Which missing relationship is preventing recovery? If that question interests you, there is more to explore on this channel. Subscribe, and we will keep looking for the answers.